Okay, so let me warm up a little bit again. So do you remember before the break we started the topic of logarithms? So if I want to remind you about logarithms a little bit, so solve a little bit of exercises today and then teach the new lesson. So I told you that if you, what is a log? A log is written in this form. You have a number in front of the log, and then you have a number here below. This is called the base of the log, and there are some conditions for A and B. I hope that you remember. The number in front of the log should be always a positive number, otherwise it is not defined. And the number which is serving as the base should be also positive, but there is one more constraint on B, and that B is not equal to 1. So whenever you see a log, these conditions are assumed to be true, okay? If that's not the case, for example, if you see log of minus 1 to the base 2, this is simply undefined, okay? So this doesn't make any sense. So if you want to write this, you have to respect these conditions. But let us say that you respect these conditions. What is the meaning of this log of a to the base b? It is asking you about a number so that when b is raised to that number, it gives you a. Sometimes it is easy to guess that number. We can calculate it on top of our head. Or sometimes we have to use our calculator, exactly like other things, yes? For example, sometimes I say square root of 4, you can immediately answer 2. Sometimes I write square root of 5, you know what that means. You know it is a number whose second power is 5, but what that number exactly is, you don't know. You can find an approximation to this by putting this in the calculator. Exactly the same story here. For example, if I ask you logarithm of 8 to the base 2, you probably don't need any calculators, because if you understand what is the meaning of a log, this is asking you, give me a number so that 2 raised to that number becomes 8. So this is easy. What that number is? So it is asking you, give me a number so that when I raise 2 to that number, the answer becomes 8. I don't think it is hard for you to guess what that question mark is 3, yes? So this means that the question mark is 3. So this means that the logarithm of 8 to the base 2 is 3. But if I ask you the same question, similar question, with 7, even I don't know what the answer is if I want to find, but still I know something. I know that this is the number so that when I raise 2 to that number, it becomes 7. But what that number exactly is, I don't know, okay? But one thing I know that 2 to the power of logarithm of 7 to the base 2 is what? This is the number, so that when I raise 2 to that number, the answer is supposed to be 7. And now I am doing that. I am raising 2 to that number. So the answer should be 7 by its definition. So this is why we had one formula, which I told you is very important, and we practice a lot. If you have forgotten, you can go and watch the videos, okay? You can fast forward it if it's long or don't have patience for it. You can just fast forward it. I think it is, I mean, this, you can listen to it by, 1.5 or even sometimes 2 is recognizable. So one formula that we learned is that a to the power of log, let me write it exactly as we did. B to the power of logarithm of a to the base b is what? It's always b. So this was the first formula. This is not the formula, to be honest. That's the definition of the logarithm, yes? So that was the first formula in our list. And then there is something that you need to know. There is a convention. So exactly like square roots, when I write this and I don't put a number there, by convention, it is assumed to be 2, yes? So here, if the base is 10, we don't write it. So if I, instead of writing logarithm of a to the base 10, we simply write it logarithm of a. So if you see a log without any base written there, it means that that base by convention is 10. And in your book, I don't know, this logarithm in base 10 is not denoted by log, they just write it as lg. I will stick to my own rules, so I will always use log. But if you read the book has written lga. But lga in the book is the same as I write loga, and it means logarithm of a to the base 10. Okay, so let us review some examples now before continuing any further. Okay, so sometimes still you can calculate some of the logarithms even if the calculator is not allowed. So I mean, sometimes it's a little bit tricky. For example, let me ask you, what is the logarithm of 1 over 81 to the base 3? Okay, so this is something that in principle you don't need calculator to calculate it, but it is not as simple as the previous one. So you have to do some calculations. Again, if you can find it in your head, just write it. If not, instead of putting a question mark is not very common in mathematics. Instead of question mark, we call it x. And I say question mark is this x I'm finding. Okay, so what is the meaning of this? I want to calculate this expression without using any calculators. Because it is hard to guess what that number is, so I have to do it in a little bit systematic way. What do I do it? I said that my goal is to find this, so this is my unknown. I call it x, and I try to find x. Okay, but when I write it x, what is the meaning of this? This means by definition, this number raised to that question mark is supposed to be 1 over 81. So this means that 3 to the power of x is 1 over 81. Okay, still it is not that easy to guess, but it is a little bit better because I wrote something in front of my eyes, I see it, and I try to solve. So do you have any idea what to do? So what is that? Yes? So what is that? Yeah, so 81, I mean, you should be a little bit good with numbers. If you have it in your memory, you know that 81 is 3 to the power of 4. If you don't have it in your memory and the calculator is not allowed, do you remember I told you something like this in Math 1C to factorize that number into prime factors? So you ask yourself, what is a prime number so that 81 is divisible by? So it is not, prime numbers are 2, 3, 5, 7, these numbers that are only divisible by themselves and 1, yes? So it is of course not divisible by 2 because it's an odd number. Is it divisible by 3? The answer is yes. So you write a 3 here and you divide 81 by 3. What's the answer? 27. And then you repeat the process. And then if you do the process correctly, always you end up with 1 here. And when you reach to that 1, the process is finished. So what is the prime number so that 27 is divisible by? It's again 3, yes? So you divide that, it becomes 9. You do the process again. So you see 3 is repeating itself. It becomes 3. And then what is the next level is again by 3, and then you see that when you do this division, finally you end up with 1. So this means that if you want to factorize 81 to a product of prime factors, there is one prime factor involved, and that is 3. It appears how many times? 4 times. So it becomes 3 times 3 times 3 times 3. So better way to write it is 3 to the power 4. So either you have it in your memory, or you have to do it in that way to find that. There's no other way if the calculator is not allowed. Okay, so then I know that next step is writing it 1 over, instead of 81, I write 3 to the power 4. But of course you have the formula sheet, but I hope that by now you have those very fundamental formulas in your head. Can I do something with 1 over 3 to the power 4? It's a very fundamental formula. I don't know, you have to remember these things, yeah? So what can I write instead of 1 over a to power n? What can I write? A to the power of negative n, if I want to. In this case, I want to, because I want to be able to compare the left side with the right side, yes? So instead of 1 over 3 to power 4, what do I write? 3 to the power of minus 4. And now it is not hard to see what x is, because on the one hand, these two numbers should be equal. On the other hand, they are powers of 3, yes? The exponent here is x, the exponent here is minus 4. They are supposed to be equal. This cannot happen unless x is minus 4. And that is exactly the number I was looking for. That is my question mark. So this process will give me that the answer to this logarithm is exactly minus 4. So sometimes the problems are given, E-level questions are at this level. You can immediately guess. But a little bit harder questions are of this type that you have to calculate. Yes? Any questions so far? If you go back and watch the previous videos, we solved much harder problems than this. So let me give you another example and wait for you to see what you do. So for example, what happens, I want to wait for you a little bit. So logarithm of 8 to the base square root of 2. I want you to answer this question without using any calculators. I will wait for you a little bit. Okay, could you find the number? Here? Yes?
Is it 6?
Yes. It is 6. Yes. Why? Because I mean, if you can't guess, you guess. Otherwise, what do? You write it as x and try to find x. There is only one way to find x, and that is the definition of the logarithm. If the logarithm of a number in a base is given to be something like this, then what is the meaning of this? It means that the base, whatever it is, raised to this number that you are supposed to find, is supposed to be equal to this number you see in front of the logs. And then you have to find this x. Okay? Okay. At any stage, if you can guess, just write it down. Okay? If you can't, you need to calculate it. So two formulas are important, I told you before. So if you have a square root of something like a box here, you can write it as what? Do you remember? Box to power. If I want to write it as a power, what can I write? 1 over a half, yes? And then there is another one that I told you is important. I'm sure about this one is in the formula sheet, but this one is not. So I want you to remember that. Okay? So what happens, this becomes box to the power of a fraction. How can I fill up the fraction? The number here goes into the denominator. The number here goes into the numerator. So these formulas are important. Okay, so here I want to use the same idea. So you know that the square root of 2 is somehow related to a power of 2. And 8 is also related to a power of 2. So that's the key observation here. So you have to fine-tune it in a way that you can see powers of 2 on the left and on the right. So what do I do? Instead of square root of 2, I write 2 to the power of 1/2 according to what I just told you. Here the box is being played by these 2. Okay? And then of course everything is raised to power x. On the right hand side, I hope that this is easy. 8 is 2 to which power? What? This is 2 to power 3. Yes? And then we had another formula. Hopefully you remember it by now, but this is also in the formula sheet. So if you have a to power x to power y, this becomes a to power x times y. Yes? So I can do the same thing here. So I have a power, I'm raising it to another power. So I write the base and I multiply the exponents. So it becomes 1/2 x. On the right hand side, I have 2 to the power of 3. And now we compare. The left hand side is a power of 2. The right hand side is also a power of 2. They are supposed to be equal. So there is only one way for making them equal, and that is to make the exponent of the left equal to the exponent of the right. So this means that, is that understandable? Yes or no? Okay, so this means that 1 over 2x should be 3. But I'm not looking for 1/2 of x, I'm looking for x, so I have to isolate x. To isolate x, I multiply everything by 2. This becomes x, and the right hand side becomes 6. So the answer to this log is 6. Is that right? Okay. So these are C-level questions, they are not A-level questions. Okay, so let me go to the list of formulas that we completed somehow to some extent in the previous lessons. So one formula, so I had it in this list, is that what happens if I have the log of number 1 in any base. So do you have any idea? Do you remember? You don't need to remember. If you just remember the definition of log, it should in principle be enough for you to be able to answer that. So here, A is the number here. It's automatically positive, so I don't need to mention it. But I have to mention B is positive and B is not equal to 1. Under these two conditions, if someone asks you log of 1, what is the answer? It's again asking you the same question. It's asking you to give me a number so that B raised to that number becomes 1. So what that number is? 0. Yes? So remember, log of 1 to any permissible, actually, you're allowed to have this B. If B is allowed to have as a base, then the logarithm of 1 to that base is always 0. So log of 1 is 0. So there was another formula in our list. What happens if I calculate the log of a number in its own base? Okay, so here of course B should be positive and B shouldn't be equal to 1 again. Under these two conditions, I am asking you to calculate the log of a number to its own base. Again, it's asking you the same question. It's asking you give me a number so that B raised to that number becomes B. So B to which power is B? 1. Yes? So if I want to say it in words, I would say the log of any number in its own base is 1, no matter how complicated the number is. For example, if I say logarithm of a square root of 5 plus square root of 2 in its own base. So whenever you see this, you immediately answer, the answer is 1, because these two numbers are the same. So these are simple ones, but do you remember any other formula that we had before the break? Number 4. So let me write some parts of it at least. If B is positive and B is not equal to 1, and X is positive and Y is positive, we had a formula. Do you remember what was it? It's a very important formula in logarithms. So, any ideas? Okay. The logarithm changes multiplication to addition. So if you have logarithm of x multiplied by y to the base b, you can apply logarithm to the first one and logarithm to the second one. But the interesting thing is you don't multiply them, you add them. I don't want to repeat that lesson from the beginning. If you are interested to see why, I proved this relation for you there. I'm just reviewing things. So that's one of the most fundamental theorems for logarithms. So for example, if I ask you, do you think that this is correct? So 12 base 2, I can write it as 2 plus logarithm 3 to the base 2. So if you ask me, Bob, like, do you know this? The answer is no. Of course, I can calculate it approximately, but I don't know the exact value. I don't know the exact value of this either. But I'm sure that whatever this number is, it is 2 units more than this number exactly. Yes? Yes? Okay, so for example, as I told you, let me just review. If you ask me what this number is, I don't know. What this number is, I don't know exactly. Even if I have calculator available, I will not be able to find the exact value of these two things. But without finding the exact values of these two numbers, I'm claiming that this number, whatever it is exactly 2 units more than this number. So how can I prove this? Using this rule that we just mentioned, yes? Because this number, logarithm of 12 to the base 2, for example, can be viewed as logarithm. Instead of 12, I can write 4 times 3, yes, and to the base 2. And then what can I do? I can write this according to this rule. I can write it logarithm of the first one, logarithm of the second one. But what should I do between them? It's a product. The product should be replaced by a sum. So it becomes sum. Yes? But if I ask you, do you know the exact value of logarithm of 4 to the base 2? It's 2. Yes? Because 2 to the power of 2 is 4. So instead of this number, I can put 2. And I copy and paste this one because this one I cannot calculate on top of my head. If you ask me what that number is, so that 2 to the that power is 3, there is a number. But that number, what it is, the only thing I know is that the question mark is somewhere between 1 and 2. Because 2 to power 1 is 2, 2 to power 2 is suddenly more than 3, it's 4. So this number is somewhere between 1 and 2. So the answer becomes logarithm of 3 to the base 2. So you see, this number, whatever it is exactly equal to that number. Yes? Any questions? For example, if I ask you what is logarithm of 2 plus logarithm of 5? If you ask me this number, I don't know exactly. If you ask me this number, I don't know exactly. I have to use the calculator, but I know the exact value of the sum. Why? Because whenever I told you, whenever you learn an equality in mathematics, it is a two-way road, yes? Sometimes you go from left to right, sometimes it is necessary to go from right to left. So you have to learn in both directions. So this one, first of all, the base is not written here. What the base here is, it's what the base is. So logarithm of 2 plus logarithm of 5. So what can I do? Yes, but why? So how can I do that? This is the other way around. The previous example was an example to tell you how to go from left to right. This is an example to tell you how to go from right to left. So Nico, what should I write here? I can write logarithm of what?
2 times 5.
Yes, so I write 1 log. So a common mistake is people write this. They somehow think that they are factoring something out. This is not factorization. Okay, so that's wrong. So the correct one is to write what? Multiplication. But 2 times 5 is 10. And this becomes logarithm of 10. This base is not written, so we know that the base is 10. So this is logarithm of 10 to which base? To base 10 itself. And if I have a logarithm of a number in its own base, the answer is always 1. So this answer is actually 1. So the sum of logarithm of 2 and 5 is always equal to 1. And then do you remember we had another formula? Anyone remembers that? There was one more formula we discussed and learned. Do you remember? No? Okay. So the formula was something like this. I told you what happens if you have a power on top of x. For example, x to power p, and then you have this base. Do you remember what will happen to that power on top of x? Yes? It goes back to the log, yes. So you can take this and move it to the back, so it becomes p multiplied by logarithm of x to the base b. Again, I want you to learn it in both directions. Sometimes you have this, it is suitable for you to write it in that way. Sometimes you have a number there, you want to get rid of it. So if you want to get rid of it, you can move it on top of that x. Yes? But of course, the conditions should also be set. B, because appears as a base, should be positive and not equal to 1. And then x appears in front of the log, so x should be positive. And p is any number that you like. This symbol, this is a Greek letter called epsilon. P epsilon r means p belongs to the set of real numbers. This is a short way of saying p is a real number. Yeah, so that is a very important rule. For example, I don't know, if I ask you to calculate logarithm of, for example, let me write 0.01. If I ask you to calculate this, again, the base is 10. Of course, you can use the previous methods that we learned. For example, you can say, I don't know the exact value of this. I call it x, and then I try to find x. So how? I would say that 10 to power x is supposed to be 0.0. Okay, but what can I write for 0.01? This is 1 over 100. And this can be written as 1 over 10 to power 2. So it can be written as 10 to power minus 2. Then when I compare these two, x becomes equal to minus 2. So that's correct. If you write that, that's okay. But now you can also write it in a little bit different way. So you can write it as log. Instead of 0.01, so you can write, I don't know, 0.1 to the power of 2. Yes? If you want to. But then you can see that this power of 2 can be moved to the back. So it becomes 2 logarithm of 0.1 to the base 10. But I hope that you can understand that this can be written as 2 log. Instead of 0.1, what you can write? You can write 1 over 10. Yes? And then instead of 1 over 10, you can write 10 to power minus 1. And then again, this minus 1, you can move it to the back. There is a 2 there. You bring minus 1 there and multiply them. So it becomes minus 2. So it becomes minus 2 logarithm of 10. That logarithm of 10 is very famous. Why? Because the base is also 10. So logarithm of 10 to the base 10 is just 1. And you multiply it by minus 2, so the answer becomes minus 2. And that's the same answer I got from that. But that's a very important property. So if you have a power on top here, if you want to, you can move it to the back and multiply to the log. Or if you have a number there, if you want to get rid of it, one way of getting rid of it is to move it and put it on top of that x. There was a formula which is not in the book. We discussed about that. I just wrote it down. So the question was that what happens if p is not here but p is there? This is not in the book, so you can read. If you have forgotten, if you're interested, you can watch the previous video. But I don't know how many of you remember the formula. So what was the formula? So let me call it 5 prime. It's not 5. I put it 5 prime because it's not in the book. So the problem is what happens if this x is x, but this b has a power p on top. Anyone? Yes?
1 over.
Yeah. It doesn't go directly to the back. P becomes 1 over p and then goes to the back. Yes? So this, I don't want you to know it if you don't like it. So this b is positive, b is not equal to 1, x is positive, and then p belongs to r. Yes? So this formula is optional. Yeah, we can just, you know, at least there is a formula, so you don't need to know about it. But something that I want to add here, and you tell me why, yes? Do you think that this is correct to write always? This is important to add. This is not in the formula sheet, but it is important to know about it. If I write a logarithm of 1 over x to any base b, can I write it as minus logarithm of x to the base b? My question is that, yeah, we can do that, but can you tell me why? If I have a fraction of 1 over x in front of my log to any base, if I want to, instead of 1 over x, I can simply write x, and then I copy and paste this b, but the price that I have to pay is to put a minus sign there. can you find the relation why this should be true? If you understand 5 in a good way, you should be able to justify this relation for why?
In 1 over x, x has an invisible power of 1.
Uh-huh.
And when you bring the x up,
Exactly. Thank you very
minus 1.
much. So that was a very good word of invisible power. Yes, so I can use that phrase from now on. So here, so 1 over, yes, exactly what you said is true. There is an invisible power here. Yes, and then the base is b. But then you just learn that if it's still on the board, if you have 1 over some x to some power, you can write it as what? X to power minus 1, and then base b. And now you see that this becomes exactly this formula, but minus 1 is playing the role of the p in the formula. So what happens to this minus 1? This minus 1 will go there. So it becomes minus 1 multiplied by what is left. What is left is logarithm of x to the base b. So if you have a box multiplied by minus 1, people usually don't write minus 1 times box because there is a simpler way to write it. People usually write it minus box. Yes, so instead of writing minus 1 times this log, I can simply write what? Minus log of x to b. I don't think it is, I don't remember exactly your formula sheet, but I don't think this formula is mentioned in the formula sheet. But it is good to have in mind that you can do it. What do you think I can do here? So for example, logarithm of x over y, do you think that's also true or not? Is there any way to flip x and y? For example, my question is to write logarithm. Let me ask my question in a different way. If I write 2 logarithms in front of your eyes, one this logarithm, one this logarithm, do you think there is a connection between them? For example, if I say this number is 5, can you immediately tell me what that number is?
1/5.
What? No, not 1/5. It's a common mistake again, because you think that I have changed this, so it should be that. No. So my question is that if someone gives you this, you should be able to immediately tell me what the other one is, if you understand the connection between these two numbers. The connection between these two numbers is very similar to this connection. Yes? If I ask you x over y and y over x are somehow connected, so how they are connected? 2 over 3 and 3 over 2. 5 over 7 and 7 over 5. How they are connected? One of them is, this is the English word for it. 2/3 and 3/2 are reciprocal of one another. Reciprocal, yes? So it is not called inverse, so you can also somehow call it inverse. So when I multiply them, the answer is what? 1. So these are reciprocal numbers. Okay? But how can I relate them with powers? One of them, so 2 over 3, this is what I want you to learn. If you want to flip these two, you can. What is the price to pay? Can you tell me? If I want to, I can flip these two, but there is a price to pay because I cannot say 2/3 is exactly equal to 3/2. It's nonsense, yes? But I can write 2 over 3 equals to 3 over 2, but I have to do some adjustments. What that adjustment is?
Times half.
No, times half makes it 3 over 4. Yes, by multiplication you can do it, but don't do it with multiplication, do it with powers. So let me just tell you, okay, the answer is this. So 2 over 3, one simple way to flip these two is flipping them, but the price that you have to pay is to put the power minus 1. Yes? Why is that? Why this is correct? Because if I ask you 3 over 2 to power minus 1, what that is, it becomes 1 over what? Whatever you have with positive power. You remember I told you a to power minus n is 1 over a to power n. So if I ask you what is 3 over 2 to the power of minus 1, you will tell me the same thing, yes? Understandable? But 3 over 2 to power 1 is just 3 over 2. And 1 over a fraction is the same fraction but flipped. So 1 over 3 over 2 is 2 over 3. So you see that 3 over 2 to the power of minus 1 is 2 over 3. Yes? So if now I want you to remember this. So if I have a fraction, let me take this brackets off. If I have a fraction and I insist to flip them, flip the numerator and the denominator, I can do that, but the price that I have to pay is to put a negative power minus 1 there. Yes? Okay, now can you tell me what is the relation between these two after all these stories I told you? Let me clean this. Now you understand what is the relation between these two fractions. Now you want to understand the relation between the logs of those fractions. So what can I do? Yes, so let me start from here. Logarithm of xy to the base b, according what I just described, and hopefully you understood. Instead of x over y, I can write y over x. But what is the price that I have to pay? Is to put a minus 1 up there. But then we just learned that if I have a power here, this power will go back. So what happens? It becomes minus 1 times logarithm of y over x to the base b. And then no one writes minus 1 times a number. People usually simply write minus that number. So it's a very interesting relation. So the relation between them we discovered is this. If I have a fraction in front, if I want, I can flip this, but the price is to put a minus sign there. Yes? Okay. Any questions so far? So this is more or less what we did before. But now I want to add one formula which is also in the book. And I think that's the last formula. And that is the case. Instead of multiplication, I want to see what happens if I have division. Okay? So partially we answered that here, but this is not in the book. This is not in the book formally. They are in the exercises. But this one is in the book formally. And then let me write number 6. Number 6 tells me if I have a log of a fraction to some base, what can I write in front? Can I split the log into 2 logs? The answer is again yes. But the answer is not very natural. You see, it was not natural. You see here, multiplication changed to addition. So this one will change to subtraction. That's also a little bit weird in the beginning. So if you have a log of a fraction or a division, you can write the log of the numerator, log of the denominator separately, but don't divide them. In this case, you have to subtract them. And this happens if x is positive, y is positive, b is positive, and b is not equal to 1. So under all these conditions, if they are met, then this is correct. Can you tell me why? This shouldn't be hard for you now. Okay, so when I will let you think as I am cleaning the board. Tell me why the log of division is the subtraction of the corresponding logs, yes? So let me write it here in front of you. So I want you to tell me why, based on what you have learned so far, whatever you need to tell me why is on the board. So we review. Why do you think the logarithm of a fraction in any base, acceptable base b, can be written as the log of the numerator to the base b, logarithm of the denominator to the base b, but subtraction between them. Why this should be true? Yes?
You can write x divided by y as x times 1 divided by y.
Very good. Very good. Yes, very good. So what you can do is to start from the left-hand side. So this becomes equal to the log. So what he said, so this is very important. I want you to really understand these things. If I say that x over y is a division, but every division can be viewed as a multiplication. This I want you to remember it in the back of your head. So if I say this symbol, this is addition, this is subtraction, this is multiplication, and this is division, for example. I want you to understand that subtraction is more or less the same as addition. Yes, any subtraction can be viewed as an addition. Any division can be viewed as a multiplication. For example, if I say a minus b, of course this is a subtraction, but a subtraction can be viewed as an addition. How?
Minus.
Yes, I say plus with the negative of the number b. And then what you just tell very correctly is that any division, which of course we usually write it as a over b, it's a division, but a division can be viewed as a multiplication by exactly what Shah said, yes? So a over b is a division, but if you want, you can interpret it as a multiplication, yes? That's exactly what he said. So instead of x over y, what can I write? I can write x multiplied by 1 over y. So remember this phrase. Subtraction is the same, more or less, not the same, can be viewed as addition. Division can always be viewed as multiplication. Sometimes they are useful, sometimes they are not. But in this case, it was useful. Okay, so now what should I do?
You can write like log x.
Based on which formula, the formula? Which number?
The fourth.
Number 4. Because number 4 tells me what to do if I have a log of a multiplication of a product. Yes? So I have a product here, and I have a log. I want to write something for it, so I know what to do. I write the log of the first one. I write the log of the second one, but the second one is this one. Okay? But I have to add them. Why? Because multiplication changes to addition in logarithms. But do you see what I can do now? That is exactly still on the board. Yes? But instead of having x there, the only difference is that instead of variable x, I have which variable here? Y. So I copy and paste the first part. Then what can I do? Instead of this one, I can write minus logarithm of y to the base b. And then so I have a plus here and a minus there. But no one writes so complicated plus and minus. We simply write what? Minus. Yes? So this is the last formula in the book. Might be, I will give you some more formulas. There is one very important formula that's very surprising that it is not in the book. I don't know why. I will discuss about that. That is the formula that allows you to change from one base to another base. So if you have a logarithm to base 2, and then if you want to write this in a base 10, what to do? Okay? But that's a very important formula, which is very strange that you don't study it. We will study it together, but I will not emphasize on it, for example, in the exam, but I want you to see it and know about it. Any questions so far? So for example, do you remember I use this to prove this new formula for you, but let us do the other way around. If I give you this formula from the beginning, could you answer this question now? you should be able to see that. Why? Because now if I start from here, I don't want to confuse you. When I ask you about this, you didn't know about this formula. So it is possible, even without knowing that formula, to know why this is true. Okay? But now let us assume that before asking you this question, I have given you this formula, and then we want to see that why this is true again. So how can I do that? I can see that I have a log of a fraction. According to the formula number 6, what can I do? I can write the logarithm of the numerator to the base b minus the logarithm of the denominator to the base b. But I told you that this is a famous one, which is on the board yet. What is that? 0. So this becomes 0 minus logarithm of x to the base b. But no one writes 0 minus a number because 0 doesn't play any role. So it becomes what? And that's another way to see the problem. Any questions? No? Okay. But now I want you to see something important here. This is something you have to have in mind. Let me see. Okay, so let me write something here for you. So for example, I write logarithm of a to the power of 2. So let me use the same letters x and y again. So x to the power of 2, but y to power 3, and I put a base b here. Can you expand it as much as possible? It's a very compact form, I agree, but if I insist you to expand this, for expanding this, there are 3 formulas involved. We will see. No, 2 formulas here actually. Okay, so what can I do first? I see that I have a log of a fraction. So what can I do? According to the formula we just learned, tell me what to write. You tell me, I will write. What should I write in front? What can I write? Hello? It's a fraction, log of a fraction. What can I do for a fraction? Log of the numerator. I'm not allowed to change the base. Log of the denominator. I'm not allowed to change the base. What should I put between them? Negatives. This is the first step. But what can I do more? What can I do with these 2? What can I do with that 3 there? I move them back to the back. Yeah, so it becomes 2 logarithm x to the base b, and then 3 goes there. There is a minus sign there, so it becomes minus 3 logarithm of y to the base b. That's it. I just want you to understand that this is a valid way of doing things. Is that understandable? But what I want you to do, this is my suggestion. After learning, I want you to be able to write this quickly in one step, okay? But that is up to you. I'm not making you hurry. I mean, take your time to understand that. But can you tell me what can happen now if I have a logarithm of b here? Let me increase the difficulty here. So I have x2 there. I have another variable z to the power of 3 here. And let me write y to the power of 4 here. And I want you to expand this. So what can I do now? I have a log of a fraction. So what can I do? I can write the log of the numerator. Yes. I can write the log of the denominator. And what should I do for them? What should I write between them? Minus. Yes, because now the first thing I did, I broke the fraction into 2 logarithms. Then I have to subtract. But for this one, what can I do? Yes? Expand that, but this time with addition, because that's multiplication. So this becomes logarithm of x2 to the same base, logarithm of z cubed to the base b, but because it was a multiplication, the sign is addition here. And then I copy and paste the last one. Yes? Now if I insist to go further, I can do something with these powers now. All of them will go back. So it becomes 2 log of x to the base b plus 3 times log of z to the base b, and then 4 goes there, minus 4 log of y to the base b. I'm not saying this is useful, but sometimes, I mean, if you see this one is equal to this, you need to understand how, and that is how. Yes? Okay. I'll give you another one. I want to wait for you. Usually people make a mistake here. I hope that you are not among those people. So I want to add one more thing here, and I want to wait for you. Okay, so let me write logarithm. I want you to expand it exactly as before. So let me write x to the power of 2, z to power 3, y to power 4, and let me add one thing here, say w to power 5, and everything to the base b. Okay, so my impression, because this is my experience, many people make a little bit of mistake here. I want to wait for you. Okay, so expand this using the rules we have learned so far. Yes, you are right. So we will have 2 positive signs, 2 negative signs. Yes. So because first of all, I want you to be able to do it in one stroke, in one step. Okay, not now, but it is possible. So be fast. When you learn something, try to do things fast. But if I want to be patient, I see I have a fraction. So what I can write the log of the numerator, whatever it is, to the base b, and logarithm of the denominator, yes, whatever it is, to the base b, but I have to subtract. Yes, that's the first thing. But then you know what to do with this one, because that's a product, so you can do it individually, but the price is to add them, not multiply them. Be careful. This is a common mistake. Sometimes people say that that's also a product, so it becomes an addition. So people sometimes write it like this. I want you to understand that is the danger here. If you write like this, it is wrong. Yes? Why? Because this minus is for the whole expression. If you don't look here, if I ask you what this is only, you will answer me this one. But this minus sign is not only for the first one, it's for the whole thing. Yes, so be careful. That is the only thing that I want to warn you about. The rest of it is simple. So the 2 goes there. And then 3 goes there. But this minus sign is not only for this one, but for that one. 4 goes there, there is a minus sign, so it becomes minus 4 log this. And this becomes minus 5 log this. Sorry, I forgot to write the base there. Is that understandable? Yes? Okay. So now sometimes you want to do the other way around. Okay? So let me write something here for you. For example, if you see something like this, be careful about. If the bases are different, the formulas not work. That they don't work. The bases should be the same. So for example, if I ask you to, what do you write about this? Let me put a base 3 here. I just write the numbers randomly. Okay, so for example, let me put 2 here and 2 there. And then I write plus 3 logarithm of 5 to the base. So let me make this one, because I want to calculate the numbers in my head. Here I put the 2, and then I write here 3. And then let me write minus logarithm of 10 to the base 3, and minus 2 logarithm of 4 to the base 3. Okay, if I ask you to collect this, how do you do that? This is the reverse process. Here I started with something compact and I expanded it. Now you see this is the expanded version. I wanted to collect everything back into one log. This is possible because the bases are all 3. Can you imagine what will happen without doing it step by step? You will have a log whose base is what? Is again the common base 3. But I want to wait for you. What should I write in front of my log? If I want to write this long expression into one log, what can I write? So do the reverse engineer in your head. Yes? Yes, Nico?
2 to the power 3 multiplied by 5 to the power 2
Uh-huh.
divided by
Divided by? Yeah, when you say, don't be distracted by negative. So you did good. Because when you saw the negative sign, you told me divide. That is for negative side.
So 10 and then multiplied.
Yes, 10, only 10. And multiplied by?
4 to power 2.
4 to power 2. Understandable? So we were able to collect all those 4 logs into one log. And of course, it is better to simplify as much as possible. Okay? Yes, don't leave it like this. There are many things we can simplify. So because the numbers are simple, let me do that. 2 to power 3 is what? 8. 5 to power 2 is 25. 10 is just 10. And 4 to power 2 is 16. But don't leave it like this, because we can simplify a lot. 8 and 16 can be simplified. 10 to 5 2 times, 5 to 5, 25 to 5 5 times, yes? So finally, what can I write? I can write log. This is 1, this is 5, so it becomes just simply 5. 2 times 2 is 4, and the base is 3. So I was able to write it in this form. Yes? So it is important to understand, to be able to go back and forth between these things. Any questions? 5 over 4. Logarithm of 5 over 4 to the base 3. So I hope that at least you understand the process, yes? It's not a hard. Okay, so let us solve some interesting questions. No, there is no time. So we stop here. I will check the attendance and then we finish the lesson. But tomorrow I will continue this lesson.